Imagine taking a human hair, hollowing it out, shooting multiple lasers through it all at the same time, and, well, using it to run Wall Street.
Yeah, it sounds a bit like science fiction.
Right. But welcome to today's deep dive, where we are taking a fascinating look at the hidden infrastructure of our digital lives.
The physical stuff that actually makes the digital world happen.
Exactly. And today we are unpacking a highly specific technical source. It's a product spec sheet for the Avenview FO-MMS-SC-SC-100 fiber optic cable.
Which is quite a mouthful.
Yeah, it really is. It's a 330-foot, 10 gigabit aqua-colored cable that costs $146.60. So, okay, let's unpack this. Why should you, the listener, care about a single commercial cable?
Well, because we constantly talk about the cloud or wireless networks, as if your data just magically floats around in the ether.
Like it's just in the air around us.
Exactly, but it doesn't. Your data lives inside physical, tangible backbones, just like this Avenview cable.
Right, but the specs on this backbone are, well, they're incredibly dense. The sheet calls it a 50/125 micrometer multimode simplex cable.
Right.
And it's noted for one-way data transfer. So a simplex cable is basically just a one-way high-speed optical highway, right?
Yeah, that's spot on. And what's fascinating here is the 50 part of that spec, that refers to a laser-optimized 50-micron core.
Okay, so how big is 50 microns?
Well, to put it in perspective, a standard human hair is about 70 microns thick.
Oh, wow.
Yeah, so you are firing data through something visibly thinner than a piece of hair.
Wait, really? But if it's that thin, how is it multimode?
Yeah.
Because the source says it supports both LED and VCSL laser light sources to, push this massive 10 gigabit bandwidth.
Right, right.
How do you cram multiple light waves into something that microscopic without them just crashing into each other?
It's all about the physics of how light actually travels. Think of throwing a bunch of super bouncy balls down a long, dark pipe.
Okay, I'm picturing it.
If you throw them at slightly different angles, they will bounce off the walls in distinct zigzag patterns.
Oh, so they don't actually hit each other.
Exactly. They can all travel down the pipe at the same time without ever colliding. That is exactly what multimode does with light waves.
Which gives you that massive bandwidth.
You got it.
Okay, so building on that highway analogy, transiting data down a glass hair sounds great, but how does it physically plug into the network? I mean, if I drop my phone, the screen shatters.
Yeah, glass is fragile.
Right. So how does a fragile 50-micron glass thread connect to a vibrating metal server without just snapping?
That is the core engineering problem here. And the source highlights these SC connectors on the ends of the cable. They use push-pull snap-in latches.
Yeah, I saw that. The text notes that the push-pull design is way easier to use in compact spaces than those older twist-style ST connectors.
Definitely.
But the sheet also heavily emphasizes a 2.5 millimeter ceramic ferrule holding the fiber. Why ceramic? Why not just use steel or heavy-duty plastic to protect the glass?
So if we connect this to the bigger picture, this design guarantees precision by combating heat. You see, servers get extremely hot.
Oh, and metal naturally expands and contracts with heat.
Exactly. If you used a metal ferrule to hold that tiny glass core, the heat expansion would shift the glass by a fraction of a millimeter.
Which I'm guessing is a big deal.
It's a huge deal. That microscopic shift would completely blind the laser. Ceramic is incredibly hard and temperature stable. It simply doesn't warp.
That is wild. And the spec sheet says these SE connectors are rated for 1,000 mating cycles. You can violently shove this piece of glass into a server 1,000 times, and it claims an insertion loss of just 0.25 decibels.
Which is an absolute triumph of engineering. By using that ceramic, you are aligning two invisible light beams perfectly 1,000 times in a row with virtually zero signal dropping out.
Incredible. Now, the source also mentions an OFNR jacket. I know this is military and telecom-grade hardware built for MAN and WAN networks, but what does the jacket actually do?
Well, OFNR stands for Optical Fiber Non-Conductive Riser. It basically means it meets stringent fire safety codes for running vertically between floors in a building.
Oh, so it's the safety thing.
Yeah. If a fire breaks out, this cable is specifically engineered so it won't act like a flammable fuse carrying the flames from the server room up to the executive suites.
So what does this all mean? Connecting this high-density, fail-proof spec sheet directly to the reality of the internet you use every day.
It means that whether you are running a high-frequency trading firm or just streaming 4K video, this exact kind of robust, fire-retardant, temperature-stable hardware is doing the invisible heavy lifting.
Which makes sense why it's a critical piece of enterprise tech. The source mentions the manufacturer backs it up with a 3-year warranty and free tech support.
Right, because the stakes for these networks are just too high for physical failure.
It really shatters the illusion of the wireless world. But here's something to think about. As our daily data needs push higher and higher toward terabytes per second, how much thinner can we slice a beam of light before the physical limits of glass simply say, no more?
That is the million-dollar question.
Where does the physical internet go from here? Think about that the next time you seamlessly connect to Wi-Fi. Thanks for joining us, and we'll catch you on the next deep dive.